Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics in MLR Institute of Technology. Today we are going to, last class we have seen multiplication by t and first shifting theorem. This lecture we are going to see division by t, evaluation of integrals by using Laplace transforms and Laplace transform of periodic functions. Let us see the statement of division by t. We know that Laplace of f of t is f bar of s. This is by definition of Laplace transform. We want Laplace transform of f of t by t. That statement says that we have to integrate f bar of s from the limits s to infinity. So, Laplace transform of f of t is f bar of s. Whatever function we get here, we just integrate between the limits s to infinity f bar of s ds. This is Laplace transform of f of t by t. Let us see one example. Find Laplace transform of sin 3t into cos t divided by t. First, let us consider Laplace transform of sin 3t cos t. So, Laplace transform of sin 3t is a by s square plus a square. This we multiply and divide with 2, that can be written as 2 sin 3t cos t. This is in the form of 2 sin a cos b. This can be written as sin of a plus b, that means 3t plus t 4t plus sin of a minus b 3t minus t, that is 2t, right. Now, let us apply linear Laplace transform by using linear property. Laplace of sin 4t, that is a by s square plus a square. Here a means 4 by s square plus 16 plus Laplace transform of sin 2t, that is 2 by s square plus 4. Let us consider this as f bar of s. Now, we want Laplace of sin 3t cos t by t. So, whatever function we get here, we integrate that between the limits s to infinity. So, integral s to infinity 1 by 2 into Laplace of 4 by s square plus 16 plus 2 by s square plus 4. We can split this. So, 1 by 2 into Laplace of 4 by s square plus a square, that can be written as 4, you take it outside, Laplace of 1 by s square plus 4 square. This is 1 by a tan inverse s by a. Here a means what? 4. So, this can be written as 1 by 4, 4 will get cancelled. So, you get tan inverse of s by 4. Similarly, Laplace of 2 by s square plus 4 can be written as tan inverse of s by 2. So, we substitute the limits from s to infinity. So, we get tan inverse of, in place of s we get pi by 2, tan inverse of infinity is pi by 2. So, we get pi by 2 plus pi by 2, this is upper limit, minus lower limit is tan inverse of s by 4 plus tan inverse of s by 2. Pi by 2 plus pi by 2 is pi, already we are multiplying with 1 by 2. So, this can be written as pi by 2 minus 1 by 2 into this value. This is how we find the Laplace transform. Now, let us see one example. Find Laplace transform of e power minus t sin t by t. First, let us find the Laplace transform of numerator, that is e power minus t sin t, right. What is Laplace transform of sin t? Laplace transform of sin a t is a by s square plus a square. Since we are multiplying with e power minus t, we apply first shifting theorem. Apply first shifting theorem, we get s should be changing from s to s plus 1. So, this can be written as 1 upon s plus 1 whole square plus 1. Now, we want Laplace transform of e power minus t sin t by t. So, whatever function we get, so Laplace transform of e power minus t sin t by t. So, we integrate this between the limits s to infinity ds. So, integral s to infinity, if you expand this, we get s square plus 2s plus 1 ds. So, we expand this, we get Laplace transform of e power minus t sin t by t. Show that integral 0 to infinity t e power minus 3t sin t dt, that is 3 by 50. We have to show that this value. Here we have to apply this Laplace transform using the basic definition, evaluation of integrals by Laplace transform. We compare Laplace transform definition. Laplace transform of f of t, basic definition is integral 0 to infinity e power minus st f of t dt. Now, we compare this with integral 0 to infinity t into e power minus 3t sin t dt. So, e power minus st, other than this remaining function you take it as f of t. Here what is f of t? T sin t. We find the Laplace transform of f of t, that is Laplace transform of t sin t. We evaluate this, at last substitute s is equal to, you compare with e power minus s, power minus s. So, s is equal to 3. So, after evaluating this Laplace transform, at last we have to substitute s equal to 3. We know that Laplace transform of t sin t is 1 by s square plus 1. We have to differentiate this since we are multiplying with t, that we have seen in the last class. So, derivative of this is minus 1, 1 by s square plus 1 derivative is minus 1 by s square plus 1 whole square into internal derivative of s square plus 1, that is 2s. So, this is 2s by s square plus 1 whole square. At last we have to substitute s equal to 3 here. So, put s equal to 3. So, this by 6 by 3 square, 9 plus 1 10 whole square. So, this is 3 by 50, that we have proved this, right. Now, let us solve this problem using Laplace transform, evaluate 0 to infinity e power minus at minus e power minus bt by t. So, first let us see what is Laplace transform of e power minus at minus e power minus bt. What is the Laplace transform of this? We know that Laplace of e power minus at is 1 upon s plus a minus 1 upon s plus b. This function we let us take it as f bar of s. Since we want evaluate this integral, just substitute. So, Laplace transform of integral 0 to infinity e power minus at minus e power minus bt by t. Since we are dividing with t, you integrate between the limits s to infinity. F bar of s is 1 upon s plus a minus 1 upon s plus b ds. We integrate this, what is 1 in the log of integration of 1 by s plus a, that is log of s plus a minus log of s plus b. Log a minus log b can be written as log of s plus a by s plus b. The limits are s to infinity. So, when you substitute the upper limit infinity, if you take common, upper limit will become 0 minus lower limit is log of s plus a by s plus b. So, this can be written as log of s plus b upon s plus a. This is how we evaluate the Laplace transform using basic definition of Laplace transform. Now, let us see Laplace transform of periodic functions. If f of t is any periodic function with some period capital T, then what will be the Laplace transform of this function f of t? Means integral 0 to capital T e power minus st f of t dt by 1 minus e power minus s t. So, this is the statement for finding the Laplace transform of periodic function. Let us solve one problem using Laplace transform basic definition. Find Laplace transform of any function f of t. Suppose if the function where the function is defined as f of t is equal to sin t whenever t lies between 0 and pi, and f of t is equal to 0 whenever t lies between pi to 2 pi. This is discontinuous function. For this function, how to find the Laplace transform? So, Laplace transform of f of t, that is equal to, using the definition of periodic functions, 1 by 1 minus e power minus 2 pi s integral 0 to 2 pi e power minus st f of t dt. This is the definition of Laplace transform using periodic functions definition. So, let us split this integral 0 to 2 pi in two intervals. One is 0 to pi, another one interval is pi to 2 pi. So, 1 upon 1 minus e power minus 2 pi s. One integral is 0 to pi e power minus st f of t. What is f of t? Whenever t lies between 0 to pi, that is sin t dt, plus another integral is pi to 2 pi e power minus st, the function is 0 dt. So, this can be written as 1 upon 1 minus e power minus 2 pi s. So, this integral e power minus st sin t dt, we have one formula, integration of e power at into sin bt dt. This can be written as e power at by a square plus b square into a sin bt minus b cos bt. Using this formula, let us evaluate this integral. Here a means s, b means 1. So, this can be written as e power minus st by s square plus 1 into a sin bt means minus s into sin t minus b means 1 into cos t. The limits are 0 to pi. When you substitute the limits 0 and pi, we get 1 upon 1 minus e power minus 2 pi s, substitute t equal to pi. So, this can be written as e power minus pi s square plus 1, sin pi is 0 minus 1 into cos pi is minus 1. So, already minus is there, minus of minus is 1. This is upper limit minus lower limit. Lower limit is substitute t equal to 0, e power 0 is 1. So, 1 upon s square plus 1, sin 0 is 0, cos 0 is 1. So, by simplifying this, we get e power minus pi s plus 1 by s square plus 1 into 1 minus e power minus 2 pi s. This is the value of s. So, this also be further can be simplified as 1 plus e power minus pi s by s square plus 1. This 1 minus e power minus 2 s can be written as 1 plus e power minus pi s into 1 minus e power minus pi s. So, this and this get cancelled. So, this can be written as 1 upon s square plus 1 to 1 minus e power minus pi s. So, this is how we evaluate the Laplace transform of any periodic function. So, in this lecture we have seen how to find the Laplace transform of any function which is divided by t, Laplace transform evaluation of integrals by using Laplace transforms, and Laplace transform of periodic function. Next class we will be seeing how to find the Laplace transform of inverse Laplace transform of any functions. This is how we see the inverse Laplace transform using partial fractions. Thank you.